Today we will continue with the second part for section two under the space unit. So we'll be talking about dangers of manned space travel. So the first danger obviously will be the launch, right? We've seen a lot of rockets, space shuttles that were blown up during the launch. There's no fails. The problem with the launch is there's no fail safe. Like there's no an extra parachute, right? Like there's no fallback safe fallback for that, right? Fuel explosive. Since the rocket is carrying huge amounts of fuel, then a small problem, a small mistake can actually cause an explosion, a huge explosion. Another one, poor weather condition can compromise equipment. Um, when there can be I don't know, a thunderstorm, those things, or during launch itself, if there's a like a really really fast wind blowing, that can alter the angle, and that can still cause a lot of problems. Falling ice fragments and foam. There was a story wherein there's this guy who, after cleaning the space shuttle, left the foam on top of the shuttle, and then during the launch, when the shuttle's moving 500 meters upward, the foam now hits the wing, one of the wings, and then damage it, creating a hole. Now, when the shuttle's about to come back to Earth, now they had a problem, and the crew, like all of the crew members, died because of that. It can be damaged heat protective tiles, those things that will prevent the shuttle from burning when they re-enter the Earth's atmosphere. Um, and in space, they have another problem with the space junk, right? Because of the like, old satellites, materials that are being thrown, and now they are in the Earth's outer orbit. They are orbiting the Earth, like thousands of satellites launched from decades ago, and now they are not being used. Those are considered space junk. So that can be a problem. So it's like navigating through those waste. If you've seen Wally, if you've seen Wally, you will see like those space junk. So meteorites. And the problem is they are moving really fast. And I told you before, when an object moves really fast, they can create a problem, like this one, right? Okay, it's this low, it's okay, right? It's not hurting me. Now, when you do this, eventually it will start to hurt you, right? um, Paint of large satellites. So regardless of the size, if it's moving really fast, then it can be very damaging. Source of debris has fallen off rockets, some satellites. What China's thinking of doing is just pushing them back to closer to the Earth, so that the Earth's gravity will pull them, and hopefully the Earth's atmosphere will burn them. So that's one of the solutions that they are thinking. Satellite explosions or collisions. So that is possible. Okay, so even if you will tell me that space is really vast, it's almost nothing, like it's a vacuum, but still there is a possibility of collision. How much junk is currently up there? Well, look here, it's pretty clear. 1960, 1965, 1970, there's a buildup already. Now at the year 1985, see, it's like an atom already, right? With the nucleus as the Earth, and then the space junk will be the electrons. And by the year 2000, see how much space junk was, how much space junk were produced through space exploration. So you have that now by the year 2009. I don't have the latest, but you will pretty much will have an idea, right? Yeah. So marble size large. So a debris as small as 0.2 mm pose a realistic threat to human space flight. So imagine 0.2 millimeters. If this is 1 millimeter, and then divide that by 5, right? Very close to how thick your hair is. And according to them, it still poses a realistic threat to humans, to humans in space. So those are the things that they need to be mindful of. So imagine like that small can still be damaging. Problems: collisions in space could fall back to Earth. So huge parts of satellites can actually will, if they will not completely burn up, like when they re-enter the Earth's atmosphere, then they can possibly hit someone or a property that can they can damage properties too. Nuclear Soviet satellites crashed. So you will see here, right, parts of a Soviet satellite. So it still is, yeah, if it's that big and moving really fast, then it can kill, a lot of people or damage huge properties. Meteoroids, um, radiations, those are the things that are, a problem in outer space. Radiation, lack of protective atmosphere. So obviously, the radiation coming from the sun will be destructive, and it can kill them. Right? It can burn up electronic circuits if there's a huge amount of heat deposited on a certain object. Then the temperature will start to to rise and then possibly burn. Right? Kills cells and vital organs, damages bone marrows. Those things are problems with radiations, and that's why spacesuits are very important. Re-entry is also another problem because severe friction can burn the shuttle. So they need to enter Earth at an angle so that they don't have a direct heat, like hit of the Earth atmosphere, so they can lessen the amount of heat or friction, right, during the re-entry. So living and surviving in space, one challenges will be space is a vacuum, no air, no water. And you've heard this before, the water, their sweat, their urine, they are all recycled for them to drink again. Obviously, they will be clean, right? The bacteria will be removed. No pressure, so no air pressure. You can't regulate your heartbeat, right? And a lot of astronauts are, they will have higher heartbeat rate, and then they will have higher blood pressure. Well, according to what I've heard before, there's no atmosphere, right? Extreme temperature ranges, so it can be really really hot when the sun is when they're facing the sun, or it can be really 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 cold. Increased radiation exposure because there's no atmosphere to stop it, then they will get all the radiation coming from the sun. Microgravity. Another problem when you go to spaces, there's no gravity or there's very little gravity, and the thing is, so how the body works is this: if I'm lifting this, okay, and since there's gravity here on Earth, then my body's telling my muscles, you need to continue to grow, otherwise you won't be able to lift this, right? But the problem is when you're going to space, since everything is weightless, your body's thinking, your brain is saying, you know what, you don't need muscles here, you don't need stronger bones, you don't need stronger skeletal system in order to support lifting weights. And that's the reason why your bones will become less dense, your muscles will be lessened. I don't know if you've seen astronauts, when they come back to Earth, they're on a wheelchair because they can't support their body weight because they've lost a lot of muscle mass and bone mass. Right, gravitational forces that act on a mass are greatly reduced, gives a feeling of weightlessness, right? And yeah, and that's the reason why they still need to do a lot of exercises. So if they can't lift weights, what they will do is they will use elastics for resistance. So that's what they will do. Body undergoes many changes in microgravity. Less pressure on the bones. Bones expand to become less dense and disuse osteoporosis. So heart does not have to pump as hard, right? So you will have a weaker heart eventually. Muscles are not used, so become weaker. Astronauts aboard the ISS exercise 2 hours every day. Imagine, right? Orientation. So no gravity. If there's no gravity, it's very hard to determine which side is down and which side is up, right? Because we know that it's down because we are being pulled down, right? But if there's no gravity, then it's very difficult to determine that. For the astronauts, what they will so looking at the Earth, that's what they will consider the floor or down. Okay, psychological. So another problem is, how will you cope, right? Without the support of your family, friends to talk to. You'll be doing a lot of work in a very small confined workspace, so that can be a problem too, right? Long absences of family members. Good thing there's internet now, so they can communicate. Living with only a few people, so that can be another problem too. Life support system. So what does ISS need to provide in order to support life? Well, clean water, obviously. That's the reason why they recycle everything. Um, I think more than 90% they were able to recycle water. Okay. from the atmosphere, from the inside the shuttle. They can recycle water, water vapor, urine, sweat, so they can recycle all of those things. Breathable air, so they have a constant supply of oxygen, comfortable temperatures, obviously, air pressure, right? Because the thing is, if there's no air pressure, then the bubbles, the gas inside your blood will start to, uh, they will try to escape, and somehow, that's what we refer to as boiling. When gas tries to escape because there's no air pressure keeping them, dissolved in your blood. Now gas will start to escape. Source of power to provide, obviously, provide energy. So eating will be a problem. So what they did is they, freeze dry most of the food that they will eat. So freeze dried because it's very, you just need to add water, then you can now eat it or drink juice or whatever. Freeze dried, it's very good because it's lighter, because there's no moisture, right? So they are lighter, so they can actually bring more because they are lighter. So eating is a problem, no refrigerator, and that's why it has to be freeze and dried, or it has to be dried in order for bacteria not to grow, right? Food usually needs a sauce or some moisture to stick to the fork or spoon, so that's another problem. So if you're soup type of person, then it's going to be a struggle for you, right? Drinks are dehydrated and come in packages. Although you can always add water, right? You can always add. Must be mixed with water. So I would encourage you to watch videos on how astronauts are doing like these things: eating, taking a shower, right, or going to the washroom. Um, in space, right? So water. So ISS recycles 93% of its water. I told you that already. Includes water, wastewater, water used for hygiene, moisture in air, those things. Oxygen creates oxygen using electrolysis. So we've talked about it. Electrolysis is basically applying electricity to water, and then one part of the electrode is positive, one part of the electrode is negative. The negative will attract hydrogen, and then the positive will attract oxygen, because oxygen is negative, right? And that's how they produce oxygen. So splits water into two. Oxygen is put into air. Hydrogen is vented into space. Sleeping. For sleeping, they are okay, seats or sleeping bags attached to the walls. Okay, so they will not be floating everywhere. Source racket stay and launch seats for entire journey. And for the ISS, or International Space Station, each astronaut has their own sleeping compartment. And sleeping bag is mounted vertically to the wall. Okay. So I'm guessing it's going to be very difficult to sleep because, so they need to be mounted, they need to be strapped, right, in order for them to be able to rest. Personal hygiene, no shower. So what they do, they have those no rinse soap, those things for their hair, or maybe, and they're also using those like cream soap that you don't need to rinse or something. Okay, so that's what they do for hair. Brushing their teeth, they will just eat the toothpaste. Actually, they don't gargle. So after they brush, they eat the toothpaste. Yeah, I know, it's disgusting. Can't spit out the toothpaste. No gravity. Develop a toothpaste that can be swallowed. So it's safe, right? Bathroom, no gravity to hold water down. So there's a vacuum. So when you're peeing, it will be sucked in. So it's like a vacuum there, and same is true for number two. So like, imagine that, right? When you're doing that, right, and then everything is floating. It's disgusting, I know. Okay. PD practice. Okay, when compared with giant star, a white dwarf is, so this is a white dwarf. So imagine, so it's always remember, as it goes up, it becomes brighter. From left going to the right, the temperature decreases. So this will be hot, and if it's lower, it's dimmer. So it's gonna be dimmer and hotter. So for next time, we'll be talking about spacesuits. For now, we will end with topic 2B. Have a good day. God bless you all.